Everyone, welcome back. Today we are going to answer an AI-103 question about benchmarking. Before we jump into question, let's start with real world challenge. Imagine opening Azure AI Foundry and seeing hundreds, not even hundreds, thousands of AI models. Like presently, we can see 11,596 models from Microsoft, OpenAI, Meta, and many more. The first question most people ask is, which model should I use? Before doing any benchmark, you really need to understand which model should I use. Should I use GPT? Should I use Claude, Pi, Llama? The good news is you don't need to understand every model. You just need a simple framework for narrowing down your choices. Today we'll cover AI model families, how architect chooses model, benchmarking explained, real Azure AI Foundry demo, AI-103 practice question, and exam tip. Our main question is related to benchmark. But before going to benchmark, how we need to select models, what are the criteria, all this is important. So I'll just cover in very brief. Understanding AI model families. When you open AI Foundry, don't try to learn every model. Instead, learn the major model families. Like example, frontier models. Example, GPT-5, Claude for deep reasoning, complex analysis, research and synthesis, multi-step agents. Memory trick is like you if you need a smartest employee, frontier models. Second is like everyday copilot models like GPT 4.1 mini, Cloud Sonnet 5.4 mini. They're best for chatbots, copilots, help desk assistants, productivity assistants, daily business tasks. Memory trick is most organizations starts here. Third is small or open models like 5.4, Llama, Mistral, OpenWIT models. They're best for cost optimization, greater control, hybrid deployments, on-premises deployment, custom solutions. Memory trick is if you need flexibility and lower cost, think of small or open models. Then we have something called specialized models. Example, GPT-5 Codex, DALI, embedding models, Whisper. They're best for coding, image generation, search, speech recognition, specific AI workloads. Memory trick, if you need specific skills, use specialized models. Last, we have something called as industry or domain models. Example is healthcare models, financial models, legal models. They're best for industry terminology, compliance requirements, domain expertise, regulated environment. Memory trick is like need industry expertise, domain model. Like this is a simple way. I try to remember the models so that I'll roughly know which models falls under what category. Here, our main question is regarding benchmark. Before starting benchmark, you cannot benchmark on thousands of models. You need to narrow down models. Now, how do we narrow down models? Now, all this is totally depend on your requirement. Let's take a real life example. Let's imagine we are building an insurance claims copilot. The AI must read claims document, analyze accident photos, generate claim summaries, assist insurance adjusters, stay within budget, deliver quality responses. Now understand the business problem. Here we are building insurance claims copilot, not a programming assistant, not an image generator, not a travel chatbot. Always start with business problem. Now let's understand priorities here. As per business, accuracy matters, cost matters, speed matters. From the business requirement, three things we require: accuracy, cost, and speed. These are our priorities we need to consider in our models so that we can shortlist these models. Now, depending on my requirement, I have shortlisted three: GPT-4o, which is a multimodal AI, Claude Sonnet, strong enterprise reasoning, 5.4, cost-effective AI, so that we now have shortlisted minimum and we can run benchmark on them. Now, why I have selected three, I'll come to that in later part of my video. Notice here something, we are not comparing 100 models. You cannot, not straightforward in, at least in Azure portal. You have to use some different methods using, say, Python. Let's start with our main question, which is related to benchmarking. What is benchmarking? Imagine you are buying a car. You don't ask which car is best. You compare speed, fuel efficiency, cost, reliability. That's benchmarking. Now in AI language, benchmarking means comparing model using objective measurements before making a deployment decision. I'm in Azure portal. We see 11,596 model. So let me select, say, general available models only, and I'll keep all the default same. And let's see, let's select GPT f 5.5. Select the latest one, or let's select the latest one. Now, if you say once you select before deploying, you will see detailed deployment benchmark. So let's click on benchmark. Azure will give you default benchmark result based on certain parameters, like for example, quality index, safety, latency, throughput, benchmark cost, and we'll try to compare the nearest model or relevant model. Like for example, quality index, higher is better. So in this case, GPT 5.5 is better. In terms of safety, lower is better. GPT 5.5 is better than other. Latency, lower is better. Here, GPT-5 is not good as compared to other. Again, higher is better. Again, GPT-5 is not better. So you roughly come to know you can compare maximum of three models. In the real enterprise world, probably this will not work, but something to start is okay because you will have to compare multiple models, not just three. And comparing three model every time it will be headache or it will take a lot of time. Comparing basic thing is fine, or else you need to use other methods like using Python code or any other method. For that, I will create a separate video, detailed video, saying using your own data, how you can compare models, because this is mostly depends on public data, benchmarks and all. Let's say change the model to say Sonnet 5 and then see MR5. Now, one interesting thing you will see is that this one will not say any data. From this, we can make out that not all models have benchmark. If you selected three models, third one doesn't have benchmark, probably you cannot compare. So again, you need another method to compare, right? So this will not work. Now, if you see here, again, same parameters, quality, safety, estimate cost, throughput, and all, you can compare. Now to start with, this is okay. Again, for me, one main thing was training data. If you see, this is 2024, 25, 26. So basically, depending on your project requirement and all, roughly if you know, you can compare. But it's not that helpful when you really deploying or building an enterprise project. The other thing which I find very useful or interesting is leaderboard. For example, you're building a project where safety is most concerns. It's like your build project is related to children. You need a higher safety. So in a leaderboard, which you see here, you can roughly see as compared to other models, which is the safest one. So that will also help you to start and compare those things. So kind of a very nice thing here, like for example, lower is better. So GPT 5.4 mini is better than other models. Now then say 90% you need to go for a cost. So in that case, lower is better. So again, you see these are the models where the cost you can compare and at least start with comparing. So it's a benchmark data. But again, you will see models which has benchmark data. You will not see model which doesn't have benchmark data. So there might be a model which is cheaper than these things and doesn't have benchmark data. So you're going to miss it. You need to take those things into considerations also. Now again, if you see that same thing, like for example, graphical way of doing this, like for example, say, let me select, say, let's compare only these three things for simplicity. Here you can say that, like for example, you can say benchmark cost. So as compared, this is 4.1 is the costliest one, then this, then let's say with respect to safety, which is the safe among all these three, it's like again, if you see safety, lower is better, so this is not good. So the best one for us is nano. So again, you can compare, but this is nice way. At least you can select or as per your requirement, parameters, configuration, business requirement, you can narrow down and use benchmark. Now let's go for our practice question. In Azure AI Foundry, you want to compare the cost and latency of two different models deployments under a simulated load. Which tool provides the data? A. Prompt flow. B. Content safety. C. Model category. D. Benchmarking. Let's eliminate content safety. Content safety helps identify harmful content, unsafe content, toxic responses, policy violation, but it does not compare cost, latency, throughput, performance. So this is out. Model catalog. Model catalog help us discover models, browse models, learn about model capabilities. Think of it as a library. However, it does not compare model performance under simulated load. So this is out. Prompt flow. Prompt flow helps us build AI workloads, test prompt chains, develop AI applications, orchestrate AI processes, but prompt flow isn't the primary tool for comparing deployment performance metrics. So this is out. The correct answer we know is benchmarking. Why benchmarking? Look at the keywords. Compare, cost, latency, simulated load. These are the classic benchmark clues. Benchmarking helps us compare quality, cost, latency, throughput before making a deployment decision. Like again, I'll repeat. Real world example is like imagine we are comparing GPT-4o, Claude Sonnet, and 5.4. Which is the fastest? Which is cheapest? Which handles more traffic? Which provides the best overall values? Benchmarking gives us data instead of assumptions. Now, what is Microsoft really testing? Microsoft isn't testing whether we memorize a menu option. Microsoft is testing whether we understand how architects make decisions. Good architects don't guess. Good architects follows this process like business problem, choose the model family, create, shortlist, benchmark, and then deploy. Exam tips is when you see compare models, compare deployments, cost comparison, latency comparison, throughput testing, simulated load. Think of benchmarking. Before you go, I did love your feedback. If there are any Azure AI, AI-103, or Azure AI Foundry topics you'd like me to cover in future practice questions, please leave a comment below. If something has changed in Azure, a model is no longer available, or you have a better real-world example, let me know in the comments as well. I'm building this question bank for the community, and your feedback helps me create more useful, practical, and high-quality content. And if you found this video helpful, please consider subscribing so you don't miss future AI 103 practice questions and Azure AI demos. Thanks for watching, and I'll see you in AI 103 practice questions 12.